Hello, good afternoon. It's Ken Miller here. Welcome to our weekly webinar of Predict, and we're going to take you through exactly how this all stacks up and works. And really, what we're going to try and do today is get to the truth. So we're going to do a little bit of myth busting on the way in, but the real show is going to be Alex. So Alex Paramore, one of our consultants, who a lot of you will know, obviously. He's going to take us through a couple of models that he's built, and if we get time, the real bonus will be he'll show us some models that he actually uses. So he builds some models over football data and regularly tweets about results and things like that as well. So it's worth watching out for what Alex does. But I'm going to start really briefly with just a bit of an overview of exactly what we mean by Pi Analytics, or the new name that we tend to put this under is Pi Predict. And essentially it is predictive analytics, and it will do one of two things. So the first thing is it will start to let you see your data in perhaps a way that you haven't seen it before. So we talk about not having to go in and look for data quite as hard. It will use a little bit of maths or some algorithms here to go through and take a look at your data and unpick it. And essentially what it's trying to do is find whatever characteristic or whatever objective that you have, so what it is that you're trying to measure, find out which of the characteristics in your data set most pull apart high or low achievement from that characteristics point of view. And really the end game is to take the output of that, which will be a model, and apply that to incoming streams of data or existing data to try and predict future behavior of a customer or a product or a device or whatever it might be. But just before we do that, we'll just take a quick step back really and sort of understand what we really mean by machine learning. And machine learning sort of dates back to the 1940s, 1950s, and Alan Turing, who is somebody I'm sure you'll be aware of, is really considered the grandfather of this sort of area of expertise. And it was the use of computer systems that Turing and his colleagues at university were able to create, that were able to drive a lot of what we actually do now forward. So a lot of what we do still isn't particularly new. It has been around a long time and has been around. And actually, if you look back and it's worth looking at Turing's work, he was able to build these things way before the computing power was there to actually prove what they were capable of doing. And really it's the ability of a computer to learn and adapt and start to apply rules without having to be given explicit instructions. And that's what we call Pi today. Just go on to the next slide, sorry. So a couple of myths to bust really at the beginning with this, which is machine learning and AI processes. They're about one thing and one thing only really, which is about the automation of processes and procedures. And it's really reducing human input required into particular processes. And it is just a tool, like all of everything that we use as humans. It's just a tool designed to make the work easier, or reduce the amount of repetitive work that we have to do, or allow us to do more with the time available to us. And that's exactly what we're trying to achieve with any kind of ML or AI process, is take away the requirement from the human to be involved in every facet of that process, and allow machines or tools or computers to take control of that. And it can be one of a couple of things really. It can be a physical process. So if you think about a factory making car parts, those factories tend to be incredibly automated these days. So it tends to be a robot welding, pressing, spraying, doing all of those functions within there. Or it could be software based. So you think about loan processing applications where there's thousands and thousands of loans to process within a day. Then we can actually get the computer to look at those different loan applications and make decisions about how and where to lend money to. And really, again, this is really nothing new at all. And in fact, if you actually sort of go back, you can go all the way back to the Greeks, where they actually had machines. And I won't even try and pronounce the name of this, but essentially it was an orrery machine. that was designed to predict when astronomical positions and eclipses that were important from a farming perspective would happen in the calendar. And they were able to use machines like this to predict that multiple decades in advance. So way before computing power, people have been putting these things together. And if you think about how complex that machine is, that was the first version that we actually know of, which is 2,000 years old, imagine just how much before that they had even simpler mechanical devices designed to predict what was going to happen. So a couple of myths about where you need to be before you start to use Panintelligence to do this. So a lot of people think that their data needs to be perfect before they do this. The truth of this is actually, no, it doesn't need to be. What you've got at the moment is enough to get started. Always, you'll now then go on a journey. So we talk about machine learning being very much a journey. And you'll see this as we go through the process with Alex, because he's going to let you into a little bit of the backstory in terms of how he's built a particular model and take you on that journey with him. But at first, what you'll actually find is when you put the data set through the analytical model, it will tell you more about your data than you knew before. And it will also actually tell you where the gaps and holes might be. And I think sometimes the word data science is a bit of an acronym, and it doesn't necessarily help. Essentially, there's a lot of art to what we do with this as well. So a lot of trial and error. And it's a tool, and particularly Panintelligence is a tool which encourages your involvement and wants you to play. So don't go thinking there's right and wrong avenues with everything. It's more about trial and error and trying things until it starts to tell you something that either you didn't know before, or when we apply those models in practicality, that actually end up being predictive, so therefore are useful to you. So the things that you're going to need to think of, and again, Alex will take you through exactly what he's looked for in his data set here, is what is my objective? What is it I'm trying to measure? So if we look at those, a couple of scenarios where we might have been involved, it might be in education. Will a child attend college? Will they go on to achieve their results? Will they go on to gain employment? In finance, will someone pay a debtor's account? Will someone become a new customer? Will somebody take a new product? All of these sorts of things, it's those sorts of outcomes that we're looking for. And regardless of the sort of area or vertical that you work in, you'll find objectives that are things that can be measured, and therefore the things that we want to predict. This will then lead you into, any data gaps. Essentially, what we're trying to do is we're trying to start building the model on things that we think will be predictive in terms of that outcome. So what are the sort of characteristics in our data set that we think lead to that? So if we went back to that student as an example, is it the student's age? Is it their previous academic qualifications? Is it something about their behaviour in the first few weeks at college? What are the sort of characteristics and things that we think would be predictive? We then just need to go looking for that data. And if that data isn't there, then we need to start to think about collecting that data for the model. But if we reflect back to that first point, really is the fact that actually we just need to get started with this as well. So sometimes things that we think might be highly predictive actually turn out to be not quite as predictive. So before spending a lot of time and therefore a lot of money on trying to find the perfect data set in these areas, sometimes it's better to start with what you have and a couple of characteristics just to see if that is looking predictive before you start. And also, play a little with the data as well. Build some charts to see what's in there. As the models come out, build some charts to look at. It's telling me that there's a very big difference between the outcome on these two characteristics. So build a little pie chart or a little bar chart to show you what those differences are, because that will help explain back to you what the model is trying to tell. So a couple of sort of term this here, the good, the bad, and the ugly, and the reasons why these projects will either succeed or fail. And just to reflect back on, Alex is going to be talking to you later about football. We'll start with a bit of an analogy of football. And really the good is when the decision taken by the machine or the software provides good evidence about the steps taken to the decision. And there's two sort of bits of technology in the world of football that have been introduced over the last 3 or 4 years. One went really, really well, and everyone universally, well, pretty much universally accepts, which is the goal line decision. And one which hasn't been received quite so well, which is VAR. And if you actually look at how these processes have both been rolled out, when it comes to the goal line decision, there's a lot of feedback given to the players and to the crowd, you know, usually via a big TV to show exactly what's happened, what the position of the ball was. And it allows them to gain trust, and it makes it feel fair when the decision is made. So actually they understand why and how that decision's been made. Whereas when you look at what goes on with VAR, and there's a good sort of screenshot there, you know, that stuck up on the screen, there's a decision being made somewhere else. Now, this is also a good example of where actually automated decisions can be a lot fairer than people making those decisions as well. You've got a set of people in a room somewhere tucked away reviewing some video, but not telling the crowd or the players what's going on, and just coming back with the decision. And that's why people tend not to like this, because it they haven't been involved in the process. They haven't been involved in the decision in a way, and therefore they don't trust it and they don't like it, and they don't like it because it doesn't feel fair. And that's something that we always should think about when we do start to look at models and introduce them. So one, using data that is understandable, but two, actually showing the method behind this, which is why we use the decision tree, so that we can clearly show exactly how we've reached the decision. Another example, so this is the bad really, and this is the whole thing which is causing fear around ML and AI, and it's really about processes that try and mimic being humans and pretend not to be humans. And an example of that I'd give you is sort of website bots, you know, those sorts of things that actually really are trying to take the place of where a human should be, and trying to use mimicry rather than show that the process is different. And there's a good example here. This is one that hit the press quite a lot last year, which was all over our TVs. Here was a boat robot that had been created to go in and cook hamburgers, and all we saw was videos of it flipping burgers on the floor and things like that. And that's because this isn't how you would build a robot to cook hamburgers. This is a robot designed to mimic humans' behaviour using humans' tools. You've got to match the process to the actual mechanism or the software. So it's not quite like a human decision. It is different and has to be different from that point of view. And then finally, it's just making sure that we use this in appropriate places. And a lot of what you'll see when people talk about AI on TV and in magazines and things is almost this humanoid robot concept. And this is one of those things that kind of makes my blood boil a little bit, because yeah, I'm sure there's going to be a case for some of these things, but when you see the appropriateness of how these things are being used. So I've just highlighted here, you know, this is a robot that people are putting together that will have emotions and gestures and mimic the human as much as possible. And wouldn't it be a suitable companion for the elderly at nursing homes? Well, perhaps maybe during this COVID period, we'd have to rely on something like that, but hopefully not. I think human-to-human companionship is something that absolutely we should not be using AI to try and remove or evolve into. So I know these are sort of trivial examples, but really got to think about exactly where and when you're using ML to make sure that it's used fairly, people understand it, and actually the application is appropriate. With all that in place, so that's the last of my sort of preamble at the beginning. We're going to get into the really interesting bit now, which is you're going to see firsthand now how Alex actually has built some data. And I think he was set a challenge by the account management team, so Holly's team, only about a week ago, to take a look at a data set. And this was a common open data set that they gave him to go and have a look at some film data and try and predict how well things would do on IMDb in terms of the Rotten Tomatoes score, so whether people would like the films or not based on all the characteristics that are available. And that's the thing that Alex is going to take us through now. So Alex, are you ready to show your screen? Holly, you may need to make Alex presenter.
I'll share my screen. There you go. Should be able to see my screen now.
I can't yet, no. So it's saying you're presenter. That's because I'm on the wrong screen.
I can see you. You're all good, Alex.
Yeah, Alex,
all good.
We can see the screen, Alex. Thank you. I'll shut up, and if you take us through the data, that would be great.
Yeah, no problem. Cheers, Ken. Hello, everyone. So, as Ken mentioned there, I've been having a look at some data for us to see what we can do, try and predict whether a film's good or not, really. So, what we started out with, well, I'll get back to the bare bones of it to start with, is in this Excel file here, wonderful Excel, we've got, I think it's 16,000 films that's provided with some characteristics around those films. So it's a free source of data. And for each of those films, we've got the year, the age group it's for. So as Ken mentioned there as well, I've the IMDb score. So this is a rating that, you know, numbers of the masses basically. This is the rating that people are giving on that site, and the same with the Rotten Tomatoes. And then the kind of interesting characteristic about those films of what are they streaming on? Can you get it on Netflix? Can you get it on Disney Plus? The director. I've got the genres there, and you can see they're all quite bunched up with different genres, different films. The country of origin of that film. I've got the language and the main languages that film is in, and then also how long the film was, so the runtime of that film. And what I did with this data at first is I just imported it into my database. So again, you know, if it's Panintelligence, we can import this into our database. And the only thing I thought about doing at first is it's great having the IMDb rating score there in this column for me. But I thought to myself, well, what do I think's a good film? What I'm trying to predict things that I want to watch, and I'm a pretty easygoing person. So I thought, well, I'll go anything over a score of 7. I'm going to trust is a reasonably good film that I can predict to watch. So, all I've done in Panintelligence was I could do it here in Excel if I wanted to, if I was more familiar with that, and say if that's greater than 7, then it's a yes, or it's a 1 and a 0. And then I can put that into my model. So I'll flip to the more interesting stuff now. So here's what I preferred earlier, so to speak. So here's the model as it was. But just to give you a little bit of a background of that, just to explain what I did there. So it's imported. I've got the data. I've connected the Panintelligence, and just to give you an idea, for example, I'm going to say it's good if it's a score over 7, and I've done a little, for anyone from the SQL side of things out there, I've done a little case statement simply to say, if it's over 7, it's a 1 or it's a 0. It could have been yes or no. I'm a bit of a database geek, so I've gone with my binary 1 or 0, and you'll see that all the way through. And I did realise that. So up here on my title, if you're seeing a 0, I'm classing it as a bad film. If you're seeing a 1, I'm classing it as a good film. So that's what I'm looking for. I'm looking for the 1. And I quickly, just to show you, it's a normal chart. I've gone and selected the analytics chart, and my objective, I've got the ID for every film there, as you saw in the nice Excel file. And my objective is I want to find films or try and predict if a film is going to get over a score of 7, and then I'm willing to watch it. And then I've added all those characteristics that you saw. Haven't changed them. I've just put them into that model there. And if I save that, and then we'll quickly load again, and straight away, just to kind of explain what's happening here and what it's telling me, what I can do with this information, is right at the top, got my first first node there, and it's saying I've got 16,000. Look at it, I've got 16,000 films or so to have a look at. Of those films, back to my one or zero, you'll get bored of this, but you'll understand it by the end, is it's saying 0 and 80%. And what that's actually telling me is basically 80% of films are bad in my criteria that I've used there. So 80% of films have a rating under 7. Okay, so I'm trying to find now that 20%. So from that node, it'll go and try and find the most significant thing in that data set of those characteristics that is going to try and predict what will get me a good film. So interestingly, you can see in that first break there is the runtime. So if the runtime is greater than 111 minutes there, we've got 2,840 films in there. You can see that now that 0 is 67%. So if I click into that, so actually, if it's a reasonably long film, it's getting upwards towards 2 hours. I've actually now got a 33% chance. Forget all the other characteristics of the film. If it's over 111 minutes or over, then I've got now nearly a 33% chance of it being a good film to watch. And then we can break and follow that node down. So actually, if it's over that, and then it's actually over 129 minutes, this then drops down to 61 of being a bad film, nearly 40% the chance of being a good film. And then they get to the really interesting bits. It's like, okay, well, I'm going to follow this down. I'm trying to find good films here. If it's on, so because in that data set, it's a 1 and a 0, again, you get used to this. This is just the binary way of saying, okay, if it's greater than 0.5, it's a 1, basically. And if it's less than 0.5, it's a 0, basically. So just look at that as a yes or no. So I'm taking yeses to the right and taking no's to the left. If it's actually available to stream on Disney, this jumps and flips. You can see now this is a 1. So what this will be showing us on all of these models is the most significant. So all the way down until we get to Disney Plus, it's actually still in the favour of being a poor film or a bad film. But now, if I follow this criteria through, and it's on Disney Plus, I've got 34 films there that have got a nearly 75%, 74% chance of being good. Like with any other charts in the software, I can add a drill down because now I'm wondering what are these 34 films. So I can click into that. I can double click and I can actually go and see what these 34 films from the data that I have are. And interestingly, it kind of starts to make a little bit of sense to me that we look down that list of films. What do Disney own? Okay, they own a franchise related to superhero films, and a lot of people like superhero films. So as we scroll down, superheroes, Star Wars, and that's something I am interested in, so I'd be happy with that. And I know now, okay, I've got my 30. If basically a film is over 2 hours and it's on Disney Plus, I probably should give it a watch. That's the conclusion. I can then actually break that down a little bit further, and because we've got a list of directors in there as well, I can actually up that from a 74% chance to an 81% chance by actually using criteria of who the director is as well. Now, if I click into that, you'll see a long list of split of directors. So that then set me on a journey of thinking, well, yeah, there is loads and loads of directors and a lot of them do the same films. So maybe I could do a next iteration of this model and I could start to split out some of this data a bit further because I've just put it in as it was. Let's just take a quick look at the other side of the model. So So you can see a lot of the directors, I would say, or film make shorter films, and that's what this path is going, showing where the path of the data is. So it's less than, and you can see as I split through here, then all of a sudden genre becomes significant as a split of whether the film is good or not. But as you probably saw, I'll flip back to it, as you probably saw from this list that I was given, this data set, there's a lot of genres flipped in together. And actually, I probably want to think, well, if it includes sci-fi, or if it includes thriller, or if it includes comedy, that's what I'm kind of, in my head, I'm thinking, well, actually, these are all bunched together. I'm not really sure what they all mean. I'd rather know, is it a bit of action, yes or no? Is it a bit of sci-fi, yes or no? So that's something that I got in my head as well. So then I can flip through and see, well, actually, on this side of the model, genre seems to be significant. Even what language it's in down here can be significant. And again, actually, the flip side of, I should definitely have Disney Plus, but on the Amazon side of things, it seems as though if it's on Amazon Prime, it's not as good as if it isn't on Amazon Prime. So maybe that's something we need to look into if I get suggested to watch Amazon Prime. So I can get all that information purely. I didn't build any of the charts. I didn't check any of the data. I just used my objective and tested those characteristics, and straight away I could leave it there, and I now know long films for Disney. But I looked into that, and because I'm a bit of a data geek as well, I can think to myself, well, actually, I'm going to do some manipulation of this data a little bit more and see what other characteristics I might be able to pull out. So then I moved along, and what I did was,
I'm just going to jump in here quickly for 2 seconds.
Yeah.
I totally forgot to ask everyone, there's a questions dialogue in the GoToWebinar control box that you've got. If you've got any questions for Alex at all as he's going through this, please drop them in there, and we'll ask them as we go along, or I'll pick them up at the end. But I apologise, I've got to ask. Sorry, Alex.
No problem, that's fine. Yeah, just ask any questions. We'll try and answer those. Is that okay, Ken? Yeah. So I'll, as I was mentioning, I decided to split the data out further. Obviously, in everybody's scenario is different. This is a film data set, and it's film. In other people's scenario, they might have much richer data already split out, depending on how it's been recorded, and that one model has solved that. Or it might be, you might have to tweak some of the data and really think about, as Ken mentioned in the kind of slides, really, about what's in my data, have I got any gaps in this data, can I check it a little bit more? So what I decided to do was do a second model. And in my second model, I just flipped it, I went through and split out the genres into their own characteristic. So instead of having one field that was just genre, I had a kind of splitting or a binning technique of saying, okay, well, if it says it's like a documentary, I want to say yes or no, or in my world, as I keep mentioning, it's a 1 or 0 in here. So if it's a greater than 0.5, that just means that it's a 1. And if it's a less than 0.5, which means just how the model's working. So I've still got my 16,000 records in this area, but I've split out further the characteristics. So now I have a few more. I've split out the genres. And I think I also split out the languages and the countries, just to keep going and keep going, just off my own head, really, just to see what was in that data. And I start again, that 80% of bad films, that 16,000, and then really what that did straight away was show that documentaries become really significant. So I've split that out, and now we see that if it's a documentary, straight away, they're nearly getting rated as a good film. You've got a 50-50 chance pretty much of it being rated as a good film if it's a documentary. Seems the world like documentaries. And then I can then split that out further. So it's giving me a little bit more detail here, a bit more of a refined model of, well, actually, if it's a documentary and it's got music in that documentary, straight away, I've got 236 films there that are going to give me about a 70% chance, 69% chance of being a good film in my rating scale. So I've historically rated films. I've now got a 70% chance that if I go and see that it's a musical documentary, I've probably got a 70% chance that it's going to be a good film. And then back to our old friend runtime. We've dropped down that. And actually, if it's a musical documentary and it's over an hour and a half, it's definitely worth watching. I've got an 81% chance there now that I can watch a good film. And then it just splits it out a little bit further, down in, I've got a characteristic that does it involve sport or not? And I'm a massive sport lover, so that upsets me a little bit. But actually, if there's no sport in it as well, so if it's a documentary, music documentary, and there's definitely no sport in it, you've got an 82% chance it's going to get a high rating for a film. And I can go in and drill down and see those 96 films if I wanted to. Sometimes, again, that might be enough. It might be a case that you look at this and you think, well, I'm not really interested in documentaries. Well, you have the ability to further advance that model and think, well, actually, I'll just filter some information out of this because I've now got a characteristic that is it a documentary or not? And I can just say, well, do a model on something that isn't a documentary. And that's all I've done in the next one, just to show you very quickly how that. So it's just an example of restricting that data. So now you can see at the top there, I'm down to 14,000 films instead, because I've excluded documentaries from here. It's not equal to one. And then we're back to our old friend again of runtime. So it's going to follow the same model. Follow that through, and I can see that actually, if it's over a certain time, it's a dramatic film, I suppose. It has drama within the film, and you can see here that if it's drama, and we're back to this really significantly, that if it's over a certain runtime, and it's a drama, and interestingly now, it's before 1991, when some people weren't born, then I've got a good chance of it being a film, a good film for me to watch. So now I can sit back and think, well, I don't really want to watch a documentary. I know a documentary is going to be a good film. I want to watch something else. I can now follow this model instead. And this is great, and this is showing me exactly what's happened in the past. It's trying to predict what films are going to be good for me to watch in this model here. But you're probably thinking, and it's like, well, how could I actually utilize this? How can I then go and find a film that I know is going to be good, or we can predict is going to be good? Well, I can apply these models to something else, to the incoming data that I got. So say, for example, as Ken said, I nicely passed some lovely film data. If that film data was updated on a daily basis, but without a score. So as films are released and no one's had time to rate them yet, I now have a model that I can apply to those films and say, well, if it's over a certain runtime, and if it's of a certain genre, and if it's about a certain director, or if it was made in a certain year, I can now predict whether I think it's going to be a good film or not, or the model can predict whether it's going to be a good film. And I'll just show you in something else related to my passion, as I mentioned about sport, of how I actually apply those models. Because what you may have noticed
Alex, it's Ken. Just before you jump onto the football, I know we're all itching to get into there, but I was just wondering if I could ask you a couple of questions that have been asked
Yeah, no problem.
on this data set before we move on to the football one.
Yeah,
So
no problem.
the first question is, where did you get the data from, and how did you load the data into the database to build from?
Okay, so this particular data set is from a good website called Kaggle, which is Kaggle, and it provides, it's kind of an open forum for great data sets to do kind of these modeling and data science, so to speak, on. And this is one of those data sets, Ken. And there's lots and lots of different ones on there to use, some more interesting than others, obviously. And then from a perspective of how I've then imported that data, it could become, I'll give you a couple of scenarios, but it could be completely different depending on what your database platform might be. But from a Panintelligence perspective, I could go to my Excel tab and I could select that Excel sheet where it is and import that data into the data connection I already have in Panintelligence from my database. I could also have a completely different database. It could be Microsoft SQL Server, it could be MySQL, it could be Oracle, it could be Postgres, and all of them have slightly different ways of importing from their own, with their own tools. But from a Panintelligence perspective, if you've connected to a particular data set or a database, you can use the Excel functionality just to connect to that and import that into that from here, Ken.
Fantastic. Yeah, that's really useful. That's the way I do it. I'll just pull down an Excel file and link it as an Excel file and do some building. And certainly where we've taken some data sets from people as a bit of a proof of concept, that's kind of how we do that. All they need to do is give us a CSV or an Excel file with some data in, and we can do some modeling for them, so they can see how that data comes from. So yeah, I totally agree. I've done exactly the same, Alex. I've got another question here, and this has come from someone called Kenny. Now, it's not me, I promise you, Alex, that this has come from. There is another Kenny out there. So this was about how you
South Park.
Yeah, exactly. Is it how you picked your objective? So the objective that you're used is good above 7, bad below 7.
Yes.
So there's a question here about that could be quite biased if you had a smaller data set. So for example, if you only had one voter for a film and gave it 9.5, so would it be better to have based the objective on some kind of a voters versus the rating? So bringing that in, would that be possible to do that sort of thing with an objective?
Yeah, so you can use several different kind of types of objectives. So in this one, I've very much, because it's my model and I've kind of decided on that objective, I suppose. And that could be the same in any business. If it's, you might have a KPI, you might have a whether, as simple as whether an invoice was paid, yes or no, or was the opportunity a success, yes or no, in CRM, I suppose. So for me, this was kind of, very bespoke from me because I chose it. But and that's very much a binary one. You can have categorical. So for example, in my football data, there's different ways of doing it. There's obviously 3 outcomes in football. So you could have a home, away, and a draw as a 3 categorical one. And like it is here, where it's showing me as a 0 or 1 yes, I would then still get which is the most significant from that. So it might be a H or an A or a D. So you can have categorical and you can have a binary format. You can also have it where I could have used the IMDb rating score, but that would find me the most significant score. So now, if, for example, because it's down to a decimal level, you're really, as the kind of person asking the question, you're really already splitting that data out a little bit too much in mind. It's not that you couldn't do it, but actually would it show you something significant? Because all it would show me is probably something around the average, and it would be might be 6.5 all the way through, and I'd see the average. Whereas I had an objective that I want to find a good film, and I made that decision on. I don't know if you have something to add with that, Ken, if that made sense.
No, it's great, and the answer is, we're never the experts, we're never the domain experts, and this is why this has been designed to be a tool for you all to use. You know far more about your own data, so even there'll be plenty of people out there who know far more about the way IMDb works than myself and Alex from this point of view as well. And the idea is anything that you can create as a formula, you can then push through as an objective. So, and going back to that point I made right at the beginning, this is a tool for you to iterate through and play with. So, absolutely, if this was your data set, the answer to that would be give it a go. Let's see what comes back, I think, from my point of view. But yeah, no, thank you for that, Alex. You carry on now. I'll keep the rest of the questions till the end. But there was a couple that just catch you on the data set.
Yeah, no, that's fine. Thanks for those, Ken. All I was really going to kind of explain is the kind of use case of this, because it's great being able to predict something, but actually how can that make a change and add value to things that are happening? So how can you use that prediction? So in my very kind of selfish potentially scenario is I'm really, really interested in football, and if unfortunately you've ever had to speak to me before, then you'll probably heard me talk to you about football. And what I've done is utilised this modelling for my own benefit, I suppose. And what I first did is exactly what I've gone through with you for now. Is I've managed to source some free data that was that exported in Excel, and then I built some models on that data around the shots, goals, fouls, etc., to see if I could start predicting football matches. I then managed to source some more data, and I managed to manipulate that data further, and it's grown and grown. And this isn't, as Ken mentioned, I think the word journey, it's been a journey for years for me, to be honest, not necessarily just this part of it. I'm finding more and more data that would help me build my model. So I'll show you an example of something I've done first, just to kind of give you a clue and to prove that I'm not making this what you can see there. Got quite a few different models about different areas of football, and apologies if you're not interested, but I think in football, but I think if you you'll appreciate what it's trying to do. So this is a football model, and I've got the ability, because it's the software, I've actually been able to add a nice calculator there, and I can filter it out for different leagues if I want to, different seasons. But for this example, I'm picking the Premier League, and I'm starting with a certain number of games. So basically, I'm trying to predict football games. And as before, I won't bore you with some of the characteristics that you can see here. They might look a little bit crazy. This is exactly the same as what we've just done before. It's that I've added as many characteristics over time that I wanted to, and found more and more data. So if this was in another world, in real life, as I might call it, and it might be that you're recording certain characteristics in your data at the moment, you think, well, that might be useful. Well, there's always the benefit of the fact that if you start recording that data, you can bring that further in, further enhance the model. So that's exactly what I did. All of a sudden, when expected goals in the world became a big thing that people talked about related to football, I went and found some expected goals data that I could put into my model. And you might see little references to that on here. But as discussed, it kind of starts again. I've got my model, and I'm trying to predict, because I'm in my binary world and my ones and zeros again, and I'm trying to find whether it's a home win or not, and I follow that down. So it starts off I've got a 46% chance of predicting a home win without even doing any characteristics. And I'm pleased to now find that down here, I've got an 81% chance of predicting a home win. So I can now, the big picture, this is great in the past, but I will, the next week's fixtures, I want to be able to try and see, well, actually, I've done all this work to find out, well, can I predict this football match? Will I be able to pick those out? And how we do that, I can go into my model, and this is where the save model element is here. And as you can probably see on this left-hand side, just to give you an idea of what's happening, is how many characteristics I've actually applied, because I don't know what is the most important. I could have built charts and charts and charts and sliced and diced information to try and find what's happened here, but I've put all those characteristics into this model to build. When I build the model, I've then got this option to save the model. What that does is provides me that it gives me an object to use that I can then apply to future data. Because if it's the same data set, and it's like a bit like the films, I've got genres, I've got directors, I've got what is streaming on. It's the same with football. I will know who the team is, I will know what their past records are. So when I get a new fixture, I can just apply that model to that, and I'll be able to see what happens. So this is models, and this is great, and I've saved my model, and I can now apply it to something. So the last bit for me is, and you'll see, we'll delve into the world of what I do over the weekend, is I created a dashboard for me that then applies these models. So I've got a probability that I can get out of that model, and I've just applied it to the incoming fixtures. So this was probably last week or the week before. And you can see, forgive my colours, but I can now, for every fixture that comes through, I've got a nice prediction about whether the chance of that particular team having a home win or not. So I could do it for draws, I could do it for away wins, I could do it for other things that I'm trying to predict. But this is just an object now that I can just apply to incoming data. And it will check the characteristics of that particular game and give me a probability of whether something's going to happen or not. And because I've got those as well, I can build a few extra charts around that. You know, what is my prediction? How am I doing in different leagues and against different seasons and things like that? I can filter that data and play around with how I need to as well. So for my world, it was great that I could just throw some characteristics into the model, save the model, and then with that same data set, I can apply it to the new fixtures that don't have the result yet and see what's happening from that. So that could be in any way. It's like, I think Ken might have mentioned it, but you know, with education, and you're predicting about students, or it might be in a hospital and predicting whether the outcome of an X-ray might be successful or not, etc., etc. It might be that you're are running surveys and you want to find what is the most significant characteristic of whether people say it's a good score or not, and which area do you need to improve on. And that's one thing that I would also mention about taking away from this. Yes, I'm looking to predict football matches, so I want to find my ones, my good things. And yes, I want to, in my films, I want to find the good films. But sometimes everybody likes to find and watch a bad film and have a laugh. So it might be interesting for me to go down the other route and see what really makes a bad film. I'm going to find some of those. In the business world, it might be the fact that actually, yes, that's great that these good things are happening, but I'm interested in this area of why isn't it happening as well. And you can monitor it from both sides, and that's the beauty of being able to add multiple characteristics without really knowing your data, without really knowing the outcome of it, just trying to find that objective and let the kind of model and do the work for you, really.
That's awesome, Alex. You know, I think it's great to see your models and see how you use use the dashboard. I've got a bit of an anecdotal story for you all, which is one day Alex phoned me up to tell me he was going to be late to work. And I asked him why, and he was beating around the bush about why he was going to be late to work. And it was because he'd got very distracted building these models and showing them to his friend. And I explained to him at the time, being late to work because you're using the product and showing it to somebody else is a very valid excuse for being late to work. I think at the time that became a bit of a folklore within Panintelligence. But
yeah, I think other people tried to use it after that, wasn't that was a problem?
Yeah.
I opened a can of worms for you.
Exactly. I've got a couple of questions, and we might have to squeeze a few of these in just to get through and finish it on the dot at 3. So we've got a question here in from Mike. So is this how betting companies create odds?
Well, I'm not an expert on betting companies, although it might look like it, but I will give my opinion. And yes, there will be some kind of regression models going over their data. And what I have found that is a lot of my probabilities using this data that's freely available to me is very similar to the odds, which in theory are just probabilities. There will be some over rounding that a betting company would do to make money. That's why they're all very rich. Yes, in theory, they would use similar models to try and get characteristics to work out why the game would be the odds it is.
Yeah, absolutely right, Alex. And I think the one differentiator really with what betting companies do is they tend to attract bets across the betting portfolio. So they're always looking to make sure that they minimize or reduce or don't have any losses depending on whatever outcome happens. So the way that betting companies sort of offlay bets between each other is quite a complex system, but it's all based on maths. And exactly as Alex says, the way that they set their original odds are based on some form of logistic regression and fundamentally on data sets that they own. So it comes down to the data, and that's the power for you guys, where you've got the data. I've got another slightly related question. I'm not going to read out who this is from, just in case we get them into trouble. But Alex, have you given up the day job yet? And have you started making money on this?
I think you can probably answer that. I'm here on a webinar, so I haven't given up the day job. It's more a passion, I would say, that helps me along in life rather than being able to give any money on it. Yes, it's I can't give too much away, but it's always done okay for me. I think it's working. I think Holly or Ken mentioned about, we did a bit of a campaign last year, and we kind of tested the model against humans, selecting the results, and it was winning that. So yeah, it's doing good.
Yeah, we should start that up again. So anyone who didn't see that, we nominated, first of all, a staff member to try and beat the model on predicting the results over the Premier League over a weekend. And then I think we got some gentle encouragement from people outside of the business. So we then had a guest every week, and tried not to upset them too much when it ended up getting ahead of where they were. So we were, when everything broke loose, we were ahead in those states. That's something that we should probably start up again, Alex. That's a good idea.
I think the issues, the one issues that we're having, and anyone who's interested in football would know that at the moment the kind of lockdown and coronavirus is quite a difficult one to predict. So that's maybe thrown a few models out, and a few of the games out not having crowds in, etc. So
I've got a question for you, Alex, and this isn't for now, but this is something we should look at. I wonder whether home advantage is different this season to other seasons, given that there aren't crowds in the stadiums.
Yes, well, it is and I do have a chart somewhere. Is the home advantage percentage is down the end of last season and this season. because yeah, away teams are having less impact from obviously the home crowd, so yeah, you know, it's not having as much of an effect. So yes, it definitely is happening. It's in the data there. So yeah, that's
Delia was right, Alex. Hopefully that chart is called "Let's Be Having You."
Yes, exactly. Yeah.
Sorry, we won't go into any more football punditry from that point of view. I've got one final question, which is actually it's not related directly to analytics, but we love your style sheet. Where can I get a hold of that?
This is a Panintelligence out of the box style sheet now. So in the latest versions, we've got multiple different options now for style sheets. So I think I'm using Pie Party, but I'll just while my screen's still there, I'll just go and quickly show you. Yeah, so my theme is Pie Party, but there are several other ones now. So yeah, you've got to do it.
I think they follow on you. That's fantastic, Alex. Thank you so much for that. That was great taking us through in really great detail in those two models in terms of how you've got to where you are, and in particular the journey that you've gone on and building those models. So thank you so much for that. I'm going to round up so that everyone can carry on with their day as well. Obviously, thanks for your time. Really appreciate it. If you do want to explore this further, then please get in touch with your account manager. There will be a follow-up after the webinar anyway. And the way we've tended to do this is by taking some data and working with you, because like everything in Panintelligence, it's more about the tool and making sure that you've got the ability to go and do whatever it is that you want to do with the tool, as opposed to us just producing the results and then you not being able to take it any further. So we've loved sort of getting involved with the data with people. And I think today we've not done this for someone's real live data set without finding something significant pretty quickly as well. So, you know, it's almost a bit of a take us up on the challenge, you know, come and have a look and let's put the data through analytics. Or if you want to do it on your own, then just take a POC of the analytics module, and your account managers will be able to sort that out. So all it remains for me to do really is thank you all very much, and absolute thanks to Alex and to Holly for setting it up and putting all the presentations together for the event today. And look out for other webinars. If you've enjoyed this, we're going to keep running webinars on fairly regular intervals now. So please join our next webinars. And thank you very much again, and have a great afternoon, everybody.